Let's go back to hollow and take a look at, we've got this thickness parameter here for the hollowed remaining mesh. Specify his thickness. Okay. Let's take a look. These are some of the major items, but one of the big ones is how do we control the fragmenting. There's a couple different ways. You saw that we just animated the threshold. That is the easiest and most direct way. There's also the fragment mask, where you can specify a bitmap. Any black value in that map is going to be no fragmenting, and as that value increases toward white, it will fully activate. And you're going to want to use that in conjunction with the threshold as well to set the fragmenting point. How bright does that map have to be in order to fragment? It's also got some gradient controls there to control that, as well as variation to add a little extra change in there, not so uniform. Experiment with low values is good, 1 to 3%, and see what you're getting. You can also control fragmenting by lights. So if a light, maybe an attenuated light, flies by and that light reaches these vertices, it's very important to know that the fragment operator depends on the vertices of the source particle mesh to detect either what the light value reaching it is or the fragment mask bitmap value is at each of those vertices. The vertices act as the detection point for when the threshold's valid and when that fragmenting is going to occur. So we can use lights to break objects apart. There's some sample files like that, and we'll take a look in a sec. We've also got crack spreading. Crack spreading is going to define a distance in world units from which, let's say we had a fragmenting point start here and only here. If we have this crack spreading set, it will spread at least 10 units away and fragment any other vertice within 10 units and cause that fragment to be born. And it's going to spread over this amount of time. So for high speed explosions, you probably want to keep this kind of low, but experiment and see what you need. So crack spreading time, we're going to go ahead and reset this back to 0 for now. Let's take a look. We've got these guys being born out here. Got a couple other options here in the fragment section. Obviously, one of the most important is which group are these fragments going to be part of. When they're born, they should belong to a specific group so that you can control them. And we've got this option here for no fragments. No fragments is going to, it's a useful compositing tool if you need to not actually see the fragments but only see the remaining mesh. What you can end up seeing is the remaining mesh as it's being eaten away. So if there's a case where you need to render that, you can always do that. Of course, also in TP3 now, up on the groups have a property called renderable, which you can use. You can just say, I don't want to render these fragment groups, still go ahead and leave them in the scene. That's another option. We've got break visible edges only. Break visible edges only is going to prevent these triangles from being born. You can see this particular face here split into a triangle. That's because for every one of these polys, there's actually 2 triangle faces. If we say break visible edges only, then it's only going to use the actual visible wireframe lines like that, and it will go ahead and then keep them in a full section, full poly. And of course, if we disable that, we're going to get those triangles again. Okay, and here into the fragment section, there's one of the next most important methods. This is the method where we get to pick how the fragmenting occurs. We can say single faces, in which case that it's going to break each of these polys into individual single triangle faces. This is really good for small particulate matter or when you need a lot of small pieces. We've got the smooth and distance. We're just going to look at the smoothing face angle between faces, as well as the radius, taking a look at the source object, the source particle, figuring out his total size, and then from that size we can specify, okay, well, how large can these fragments be? At 50% they're very large. You may want to get down into the 5 to 20 range here. And if we increase the smoothing angle, you can see that it's going to allow greater curvature. So that is what that does for us. Smooth and distance. This is really good. We're going to take a look later in a different video at how to use Pro Cutter to cut up an object into solid elements. And when we do that, we're going to use a method where we set our smoothing angle to be 180 and our radius to be 100. And that's going to be useful for breaking an object who's composed of solid elements into allowing each one of those elements to become an actual fragment particle on its own. But that's a different kind of method. We'll take a look at that. Then we've got this last but not least, the count method, which is where we can actually specify how many fragment particles are we going to want to born in total. And it's only going to give us 5 at this point. 5's not a whole lot, but you can see what it does for shape-wise. We could take these 5, maybe create another fragment group, and then blow each one of these fragments into more fragments. That's totally possible. Let's go ahead and increase this a little bit more. And we can see that we're getting quite a few more particles. The shapes are all broken up. Let's go ahead and turn on break visible edges only. And you can see that now it's going to be constrained to only use the actual full poly shape. And that's just an artistic call. Depends how you want them to look. We'll go ahead and turn that off and take a look at our next method here, sorting. Sorting's is kind of an interesting one. This is really useful when we've done this kind of simple fragmenting here where we just animate the threshold. If you use lights or maps, sorting is not going to do a whole lot for you. What'll happen with sorting is it's going to say, and actually let's increase our count here quite a bit. It's going to control the direction of the fragmenting if none is specified with the mask or the lights. And so we're going to fragment from the bottom up toward the top, and so you can see this starting at the bottom, moving up to the top. It's pretty straightforward. And then there's all these different methods here to control the direction.